Why airplanes don't fall from the sky? Thousands of airplanes fly across the world every day. Each weighs hundreds of tons, yet they stay in the air for hours. So, why don't they fall from the sky? The answer lies in physics and engineering. Let's break it down. The four forces of flight. To understand flight, we need to talk about four key forces. Lift, which pushes the plane upward; thrust, which moves it forward; weight, which pulls it down; and drag, which resists the motion. When these forces are in balance, the plane stays safely in the air. How air creates lift. The secret lies in the shape of the wing, the airfoil. An airplane wing is curved on top and flatter below. As the plane moves forward, air splits. Fast moving air goes over the top, slower air moves under the bottom. According to Bernoulli's principle, faster air has lower pressure, so the pressure beneath the wing is greater, pushing the wing and the plane upward. That's lift, the invisible hand keeping airplanes afloat. Thrust versus drag. Engines create thrust, pulling the plane forward through the air, but air pushes back. That's drag. As long as thrust is greater than drag, the airplane keeps moving forward and the wings keep producing lift. When the engine slows down, the balance shifts and the plane begins to descend. Controlled flight, not magic. Airplanes aren't floating, they are constantly moving through the air. If they don't if they stop moving forward, they stop flying. That's why even during landing, pilots maintain speed and angle to keep enough lift until touchdown. Flight is all about control, not defying gravity. The role of angle of attack. The angle of attack, the tilt of the wing relative to the airflow, is critical for maintaining lift. Too shallow and lift decreases; too steep and air can't flow smoothly, causing stall. Where the plane loses lift, pilots and onboard computers constantly adjust this angle to stay in the safe flight zone. Stability and control surfaces. Wings aren't the only things keeping airplanes steady. The tail prevents unwanted pitching; the rudder controls side movement; and the ailerons on the wings roll the plane left or right. Together, these surfaces let pilots control pitch, roll and yaw, the three axes of flight. Engineering precision ensures stability even in turbulence. The role of computers and sensors. Modern airplanes are flying computers. Dozens of sensors constantly monitor airspeed, altitude, pressure, engine power. Autopilot systems adjust tiny control surfaces hundreds of times per second to keep the aircraft balanced and efficient. It's engineering at it is engineering at its most elegant. Humans and machines working together to keep flight stable and safe. So why don't airplanes fall? Because lift, thrust, control and precision engineering work together perfectly. Airplanes don't stay up by luck, they stay up by physics, design and constant motion. The moment any of those fail, backup systems and aerodynamic principles step in to keep flight safe. That's why modern air travel is one of the safest forms of transportation ever created. In conclusion, airplanes are more than metal and engines, they are masterpieces of physics in motion. Every takeoff is a lesson in aerodynamics. Every flight is proof that human engineering can turn air itself into a road. For more stories like this on engineering that makes flight possible, please like, share and subscribe. Thank you.